All right. And then let's hop here. Let me check one more time for any stragglers. Looking good. Okay, cool. I'm gonna share the screen and let's get the party started. Let's start off here. All right, greetings YouTube, greetings scholars. Hopefully those sets are not mutually exclusive. Let me see, so this is the end of week 6, right? So only real alert is that just wanna, at week 8, we can anticipate exam 2 covering the material from weeks 5, 6, and 7, right? So we have this, we're wrapping up the material from this week, then we have whatever we talk about next week, and then the following week, we can anticipate exam 2. The main things, as usual, this is remote asynchronous, so if you've gotten your attendance credit, you're not obligated to stay. Sometimes I do get a little peeved when people leave, but it's, this is the agreement. So I think this still makes this, I still feel like this is still the better system for everybody's sanity and sake, I just got to stuff my ego a little bit, but it's okay. As usual, as we kind of go through the presentation, if you have questions or if anything is not clear, just feel free to unmute yourself to get my attention. That's the best way. The original intent is for class time to be used as like office hours or like a study session, right? So I just fill it with the lecture and homework. And so if you would like to go through a specific question, just get my attention and request it and we can talk about it. Otherwise, what I'd like to do today is to go through as many homework questions as possible. And we'll probably be doing like polls. I'm going to be doing like a lot of poll the audience and, whenever that pops up, whenever we get that opportunity. So just be on the lookout for that. We're going to be doing that in just a few minutes, right? This is a little bit different. It's not anything super, super fun or exciting, but it's a little bit different. So I got to relog into all of this, I bet, because I rebooted this thing. All right. Okay, let me see. Is this working? Come on. Allow. And God is good. Let's see, all the time. Yes, this looks correct. We are in week 6, 3.3. So that means next week is 3.4. Okay, so let's just start with question number 1. Again, looks like we have a total of 8 questions. So we'll get through as many of them together as we can. And again, if you'd like me to jump to a specific question, we can do that as well. Okay, so this starts out with, and I'll check attendance again in about 4 minutes. It's 111, awesome, angel number. I'll check attendance again in about 3 minutes, around the 15-minute mark. So use log base b of 3 equals 1.099 and or log base b of 7 equals 1.946 to find log base b of 21, right? So for this one on rules of logarithms, I think that, so 21, right? This looks like a application of the product rule. We had the log of the product is the same as the sum of the logs, right? So 21, log of 21, let's write this one out. Let me take some notes. Okay, so this one is not perfect. Let's do this. That looks a little bit better. We don't need this. Okay. In my earlier class, we didn't need to write anything for what we were doing, but that's okay. Like this. Like this. Okay, cool. And then we want to take this. Right here. And let me add a page, maybe a couple of pages. Okay. Let's take you. Come right here. All right. So this is the first question from section 3.3. This is question number 1 from the back of the text. The question ID is 3.3.1. Okay, so the product rule, right? So they're asking us to use the given information to find log base b of 21. So the product rule is like what we can apply here. This is going to be the same as, we can rewrite this as log base b 21 is what? 3 times 7, like this, all right? So then the product rule says that the log of the product is the same as the sum of the logs. So we can break this apart into log base b, that's not a b, log base b of 3 plus log base b of 7, right? And then we were given that log base b of 3 is 1.099 plus log base b of 7 is 1.946. Okay, let's break out our trusty dusty rusty. Okay, we need this one. And then once we finish this, cool, looking good. Reload and refresh. Awesome. So then we're just going to do 1.099 plus 1.946. Okay, 3.045. Okay. Hopefully that was okay. Like this. Let me submit this result and then I'll check attendance. 3.045. And we want this one. Oh no. Yeah, there it is. Let's see, full screen. Let me get rid of this one. 3.045 and off. Turn it off. 3. Let's try that one more time. 3.045. Come on. Let's try it one more time. 3. No? Okay. 3. Why is the keyboard not working? Yes. Okay. 3.045. All right. Go ahead. Let me check it. Let me check attendance real quick. Give me just a moment. Give me just a moment. Let me stop the screen share. Okay, go ahead.
So on Pearson, when I do an assignment, it's really the assignments that have like the square roots of, well, not like the square roots, but like the fractions of like when you're asking us to apply multiple logarithm rules.
Okay.
So like when I would get the answer right, but Pearson would say that it's wrong because of like a formatting thing or something.
Yeah. Okay. So with those, Pearson does want you to be precise. So you do have to follow the instructions to the T. For the homework, I would say for the homework, just do the best that you can. When you get on the exam, if that happens, bring it to my attention and we can talk about it. Now in the homework, if you can find an example of when that's happening, click on the Ask My Instructor and it'll email me and we can look at it. If you can't find it right now, that's okay. But again, if you get on the exam and that happens, bring it to my attention. I'll pull it up. We can look at it, talk about it, and see, make sure that, because you're right, sometimes that does happen. But you have to be like to the T, right? With proper rounding. When you if you're crunching numbers as you're working through these, do not round into the very end, right? Like, so like if you're crunching numbers intermediately, if you get a long decimal, you want to be as exact as possible. So do not round. So that means if you're gonna crunch the number early, you got to write that decimal all the way out. You got to keep doing that until you get to the very end.
So it wouldn't be. I'm sorry. I don't mean to cut you off.
You good.
But it wouldn't be like a decimal thing or like a rounding thing. It would be like, okay, so I'll email you this one.
Okay. You want me to pull it up right now? We can.
Yeah.
Okay. Hang on. Let me take a look at the next one while you get it preparing that one. Do you know what number it is?
It's number 4 on the
Let me pull.
rules.
Let me try this number 4. I know the numbers might be different, right? But it should be the same style. Does this look good? Where we got the log of x times x plus 2?
Oh wait, your screen's not sharing.
Oh, okay. Hang on. Like this. Let's try it again. Share the screen. It says it's already. Okay, here, let's try it again. Come on, share the screen. Okay. All right. So for instance, if we look at this one, this is the log, natural log of x times x plus 2. We're writing in expanded form.
Well, I'm sorry. Are you sharing? Because it's not showing. It's
You
showing
should
a
be,
black
yeah.
screen.
Still no look? Anybody else can see my screen?
See the screen? Your screen?
Yeah, can you see my screen?
Yeah, I can see it.
Did you email me the one that you were referring to? You guys there? Because this is number 4.
I'm sorry. The name should be Charles Dales.
Did you so can you see it?
No, it's showing a black screen.
Try moving some stuff around in Zoom to see if you can just shift it around some. Because there's nothing else for me to do as far as sharing my screen. Let me see if I can pull up this email. Okay, I see it. Let's take a look at it. So I'll probably just work. Yeah, this one, right?
So like I would get the answer right, but the only difference is like they had spaces or something in the answer.
Let me see.
Wait a second. I'm sorry, because I still can't see your screen. I'm going to leave and I'm going to try to rejoin.
Okay. Yeah, looking at yours, it shouldn't be any space. Okay, so it does seem like it's a formatting thing. Like for instance, this one. All right, so this is the product rule, right? So it would be natural log. So I'm gonna do ln. Oh, come on, keyboard. Why are you doing this? Okay, let's try this. ln. I don't understand why it's not working. This keyboard is annoying. All right, I might have to put it to the side. Keyboard is not supposed to be that distracting. Okay, so maybe it's something with my settings because it is registering the keyboard, on-screen keyboard, accessibility. If you want to use a screen reader or navigate exclusively, let me turn that on and hit OK. Maybe that's what it is. Okay, maybe that's what it is. Okay, so this one, no. Accessibility. It's not picking up. Okay. Let's turn this off. I tried this one already as well. Okay, that's part of the reason. So let's do function like this. No. Sorry. Okay, let's try it now. Yeah, I don't like this keyboard. All right. I don't understand why it's not picking up. See, it works there. Yeah, that's so weird. Okay, so let's do this. I'm gonna just have to use the on-screen keyboard, which is like annoying, but if it works, so let's try this. ln, so this should be the natural log of x plus, you're good, sorry, plus the natural log, nope. Yeah, I don't like this keyboard. My YouTube is going. All right. I don't understand why it's not picking. There you go. Man, this thing is like, I told you, it's like, it's just throwing a tantrum today. X plus 2, right? And that might need to be in a grouping symbol, like the x plus 2. So let me see if we don't need it first. I'm gonna hit enter and see what happens. Okay, only other thing I could think to do, you know, is the x plus 2 has to be grouped, right? Is the grouping there. Oh, I'm still trying to use this keyboard. Parentheses and parentheses, right? Because otherwise it looks at it as if it's saying natural log of x plus natural log of x plus 2, right? So you need the grouping so you can be clear that the x plus 2 is inside the log. Okay, let me look at yours. Yeah, you got the grouping. It probably is a spacing. I didn't really do any spacing, and it should be ln, right? So just make sure you're doing ln when you type it. But again, if something like that happened on an exam, I would just make sure that you have your credit. Let's go back and let's kind of go in order until another one is requested. Given that log, given that log base c of 2 is this, log base c of 4 is this, and log base c of 6 is this, find log base c of 4 divided by c. Okay, let me take some notes on this one. Let's take some notes here. And it's not a lot of writing that needs to happen, but I feel like this one would be better just if we write it out. Okay. We wanted to go right here. Let me see if that, maybe that'll fix it. Because this happened before and I've fixed it before. Okay, let's do this. Okay. Hopefully you guys can still see my screen. Let me see. So we're asked to find, let's start here. So we have log base c of 4 divided by c, okay? So the log of the quotient becomes the difference of the log. So this would be log base c of 4 minus log base c of c, all right? Okay, so then log base c of 4 is 1.124 minus log base c of c is 1. So then the final result ends up being 0.124. Can I paste? No. Paste. Oh, cool. Yeah, that's exactly what I wanted. Okay. So we got 0.124. All right. So let me see if I go here. Right here. One more time. There it is. 0.124. Awesome sauce. So let's turn this off this time, see if it works. Check. Boom. All right. Okay, so if anything isn't clear, just stop me. We can go back and talk about it. Let's try another one. Given some initial conditions, evaluate the following expression without using a calculator. Cool. So we're just expanding. It has the log of x is 2, log of y is 7. Let's write this one out. Let's write it out. Let me zoom in just a little bit. This one. No, let's go back. That's not necessary. Okay. Type an integer or a decimal. So let's take some notes on this one. Come on. So we'll go from here. Here. All right. All right. Come on. There it is. Jesus. Like, I don't understand why that was so hard. Okay. So we're given this initial stuff. We're asked to evaluate this expression without a calculator, right? So then we have log of 4x squared times y. So let's expand this. We can expand this into log of 4. And I'm gonna go ahead and apply the power rule. If we take the log of x squared, that power can come in front. So log of x squared is going to be the same as 2 times the log of x plus the log of y, right? So I kind of skipped a step for the x squared, right? This would have been log of x squared, but I went on and applied the power rule so that 2 can come down in front. It came down in front like that, okay? So from here, we can just apply what was given. Log of 4, it says is 0.6 plus 2 times the log of x. Wait a minute. Yeah, log of x is what, 2? Plus the log of y is 7. So what is that? 4 plus 7 is what, 11? So then 11.6. So all we did was expand it, and then once we got it into completely expanded form, we use what was given to generate that number 11.6. Awesome sauce. Like, I don't understand like what I did to make my keyboard work. I know I did something. I think I just turned it off and on, and now it's working, but that's fine. And I think it's something with like the updates or something. But I said something like 12 times in like 3 seconds. Okay, so we did this one. Let's go on to the next one. Let me check Zoom really quickly, just to check on you guys. The chat looks okay. And let me get these stragglers. Let's see, like this. Okay. So then, oh, he was here. He got knocked out. No, he is still here. That's okay. And then this student. Okay. All right, let's go back to sharing our screen. Start the broadcast. Here we go. Man. It's like pulling teeth. Okay. So this one, if we take a look here, it says use the properties of log to expand the logarithmic expression as much as possible. Evaluate without using a calculator if possible. Okay, I feel like I can do this one on the fly. So basically it's going to be the log of the top minus the log of the bottom. Then we're going to have like power rules. Yeah, I don't feel like I need to write it out. If I do need to write it out, just let me know and I will. But I'm going to try to do this on the fly. Okay. So essentially what we're doing, we're saying the log of the top minus the log of the bottom, right? So right here. So the natural log. Now, if we just focus on the top, now when we focus on the log of the top, we have 2 main products. We have the log of that first part times the log of that second part, right? So when we say the log of that first part is going to, you can bring that power down. So that's going to become 7 times the log of x. And then we can say plus 1/2. You want to work? Okay, that's fine. 1/2 times the log of that second part, x squared plus 2, right? Remember, there's no sum rule, so we can't break apart that log of the sum. We can't break that apart. Now, I think that's the top part, it completely expanded, so then we want to say minus the bottom part is just one piece. The log of the bottom, we can apply the power rule, so there's going to be 4 log of that sum. Okay, I know that was a little bit intense. I feel like this is it. Let's give it a go. And you just have to stop me if anything is not clear there. Okay, otherwise I'm just going to move on along. Hopefully you guys I do encourage you to work together. There should be a group me or something going. I think it's a great idea as long as you can get it on some level. And also hopefully you guys have sought out the tutors, right? They're included in your tuition. So if you can't get it from me for whatever reasons, either hopefully you can get it from a classmate that gets it or from a tutor. That's because that's what I was doing. Okay, when I was a student. Okay, so we want to expand this one, right? So it's the same kind of deal. We just have to choose it. Okay, so with this one, let's zoom out a little bit. And I think I would like to poll the audience here, if I can get this to behave proper. Come on. There it is. Oh no. That's okay. We just got started. So hope it's okay. Let me just bring it back like this. That is decent. That is what I wanted. And we're going to poll the audience with this one. So what I'm going to do is open up my poll here. I want at least 50% participation. We got 12 people. So if I can get at least 6 people to partake in the poll, let's launch it. All right, so I just launched the poll. We have 4 options. It's either A, B, C, or D, right? The poll is anonymous. I'm just going to try to fill the air until, well, obviously it's not E because there's no option for E. I'll count that as participation, right? But what do you think it is? Is it A, B, C, or D, right? So I'm just going to kind of chatter until I say 30% participation. We need like 5 more. Okay, there's a vote for B. There's a vote for B. Let me see. So if we start to expand this, right, the log of the top becomes 2 times the log of that. Okay, B is looking promising. B is looking promising. I need what, like 4, maybe 5 more people. We got some people, right? And it's anonymous, so okay. I don't know. I'm gonna let it be for now. Because obviously E is not one of the choices. Let's get, okay, I got my 50%. So let me see. Most people are saying B. I'm going to blindly go with B. I'm not going to check it. Does anybody want to like explain that to us? Like somebody that chose B? Anybody want to explain it before I submit it? Going once, going twice? A brave soul? All right, let's go with B. Let's see what happens. All right. I guess you are smarter than a 5th grader. Let's go on to the next question. That was good. All right, so no poll on this one, so we're gonna let that be for right now. Write the sum. I'm still laughing because I'm like, come on. There's no option for E. Write the sum as a log of, okay, so now we're working backwards, right? So we're given the solution, like before we were expanding the logs, now we're condensing the logs. Now we're given the solution that we want to work backwards and see can we get to the result, the starting point, right? So this looks like the reverse of the product rule. So that means we should be able to condense this into log, let's see, nope, that wasn't it. This one, no, this one, no, this one, there it is. Log base 4, there we go. I think 7 times Z, right? 7Z, let's go with it. All right, if anything is not clear, you just have to get my attention and speak up. My philosophy is the only dumb question is the one that asks. A closed mouth does not get fed, right? So if you don't say anything, if you don't speak up, it's a lot harder to assist. Write the following expression in condensed form. So again, we're still working backwards. Now, if we look at, this is all addition, right? So it looks like the reverse of the product rule, but there's an additional one that we're applying is the power rule, right? So if we work backwards, applying the power rule with the product rule, that 2 log of Q is going to become log of Q squared. That 4 log of R is going to be the log of R to the 4. So then ultimately, it looks like we're going to get ln P Q squared. Let me see if I can get out of this, okay? Times R to the power of 4. Cross our fingers and God is good, okay? All the time. All the time, right? Okay, next question. Use it, okay, change of base, right? So this is one that I was kind of eager to talk about when I was doing the lecture or the presentation and it never came up, but I know it was in the full lecture that's on my channel. So change of base, for instance, suppose you wanted to evaluate something like this in your calculator. We have log of 30 base 2, but in the calculator, if that base 2 were not written there, then the implied base is base 10. Common log is generally base 10, right? So if we wanted to evaluate something like this in our calculator, we would have to use a change of base formula. And basically, we would have to say the log of 30 divided by the log of 2, right? That's the change of base formula. I kept wanting to use it, but I was like, well, let me just try to hold off until it pops up. Do not round it to the final answer. So if we wanted to quickly do this in the calculator, see if I go like this. There it is. I want this guy. Right? So change of base, all we have to do is say the log of 30, close parentheses, divided by the log of 2. That's the change of base one, right? Okay. Round to 4 decimal places, 90, 69. 90, 69. Come on. You're doing that thing again. 4.90, 69. I think that's right. Let me check one more time. That looks good. Check the answer. Come on. All right. So that was an application of the change of base formula. Use the calculator and the change of base change formula to find a log to 4 decimal places. All right, same thing. So we have the log of 7 base 1/10, right? So in our calculator, all we're gonna do, we're just gonna say the log of 7, close parentheses, divided by the log of 1/10. Okay. 4 decimal places as needed. So then we get negative 0.84. It would be 50, but that 9 tells us we need to round up 1, so 84.51. 84.51. Cross our fingers. God is good. Again, you just have to stop. We got a solid 4 minutes. Let's try to maximize this 4 minutes. Maximum effort, right? Use the change of base formula to approximate. So again, calculator, right? All you're doing in your calculator is the log of 4. Come on. Divided by the log of 2. Okay. Plus the log of 7 divided by the log of 2. That's not the log of 2. Right? That's how we account for that different base. Decimal rounded to the nearest thousandth is 3 decimal places. So it's 807, 4.807. Awesome sauce. I think we got time for another one. We did that one in record time. All right, simplify. Okay. Let's write this one out. Let's write this might be the last one. Okay. We got log base t of the 9th root. Log base t of the 9th root of t. See, log base t of the 9th root of t. This is and so there's a question ID is number 12 in the homework, okay? Simplify. So the 9th root is the same as, we can rewrite that as a rational exponent. So this is going to be log base t of t to the 9th root is the same as to the power of 1/9. Then we can apply the power rule. Okay. So then we're going to have 1/9 times the log base t of t. Log base t of t is 1. So then this is just 1/9. Okay, I think we're out of time. Okay, we started working out the kinks. Let's try 1/9. Let's hit the X there. This one. Let's try 1/9. Awesome sauce. Awesome. I think we can get another one in there. Find the value without using a calculator. Okay. Let me think about it. Okay. Let me write this one out. This one looks interesting. Okay. Okay. Yeah, there you go. Cool. Okay. Find a value without using a calculator, right? So let's start here. We got 7 to the power of, now we got this 2 log base 7. That doesn't look like a 7. Base 7 of 6 plus log base 7, that's still not a 7. I don't know why I keep writing this as E7 of 2, right? So when we have a base raised to a power where with the power plus another power, then to expand that, what we're getting, this we can rewrite this as 7 to the power of 2 log base 7 of 6 times 7 to the power of log base 7 of 2, right? So that plus, we can break it up into this form. Now, if I focus on this power here, this 2 times the log, that 2 can go to the exponent, right? So this 2 can go up and become the power of that 6, okay? So then we're gonna have 7 to the power of log base 7 of basically 6 squared, okay? Times 7, I'm gonna leave this one for now, log base 7 of 2, okay? So because logs and exponents are inverses of each other, this 7 is canceled by this guy here. Thank you. This 7 is canceled by this guy here. Okay. Hopefully I'm doing this right. So then what is that? Okay. This should be equal to 6 squared times 2. I think that's 74. Okay, let's try 74. Hopefully I did that right. All right, so let's hop over here. We got 74 when we did it. 74. Okay. Let me think about it. Then when you add the exponents, 36, 70, 72. That cancels. 36. Oh, okay. 72, right? I don't know where I got 74. Yeah, 72. Just did my calculation wrong. Let's try 72. I think that was 72. I don't know why I put 74. Okay. All right. Are there any questions? Let me see. We didn't really write that much, but let me just go ahead and share what we did write. Okay. So we did a demo. I think we addressed some questions. Let me go ahead and send this to Box. So if I go to Box, not College Algebra 1, this is fall, College Algebra 2, into the notes section, right? Okay. So if you go to like our Blackboard page, you'll get a copy of the stuff that you saw me writing today. If there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy your weekend. All right, guys, take care. Peace.